Hello, guys. Hello, can you hear me? Hello, Pilar, how are you? Hello, Adito, how are you? Can you guys hear me? Hello? Adito, can you hear me?
Hello.
Yes? Okay. Pilar, can you hear me?
Yes,
Pilar,
Miss Amanda.
Hi, honey, how are you?
I'm fine, thank you.
Great. I'm here for you if you have questions. Do you have questions? Pilar, do you have a question for me? Or Adito, do you have a question for me? The meeting is for you to ask any questions that you have. Do you have questions? You can raise your hand if you have a question. Adito, do you have any questions? Adito, do you have questions for me?
No.
I can't hear you. I can't hear you, honey,
No.
at all.
Miss
No
Amanda.
questions?
Miss Amanda.
Adito, no. One second, Pilar. Adito, no questions?
I don't have questions.
Adito, I can't hear you. Your mic is making noise. I can't hear what you're saying.
I don't have questions.
Have any questions? Okay. Pilar, do you have questions for me? What's your question, honey?
Miss Amanda, I want to ask you what I don't understand what we are going to do in the story that we are going to write it.
Your personal narrative?
Yes.
You're supposed to write a story about yourself. I put 2 examples for you on the Smart School. I put a video telling you how to write personal narratives. And you're supposed to write a story that happened to you. Okay? And in the project sheet, it tells you to write the story. You have to write the chart where you put the list of events that happens and put them in order in the chart, just like the chart that we made on the on Smart School. There are 2 examples for you to follow. And there are also notes about personal narratives and videos about personal narratives, okay? A personal narrative is a story about yourself, something that actually happened to you. You have to make a sequence chart, which means you list the events that actually happened, and then you write the paragraphs that explain your story, okay? You use the information from the chart to write the story. And after you write the story, you're going to draw an illustration about your story. Okay?
Okay.
Okay. You understand now?
Yes.
Okay, if you have any other questions, you send them to me, okay?
Okay.
Okay, honey. Any more questions? Do you have more questions for me, honey?
No, thank you.
Okay. You're welcome, sweetheart. Adito, do you have any more questions for me? Hello? Adito? Do you guys have any questions? If you have a question, please raise your hand. Adito, no questions, honey? You understand everything? Adito?
Yes, I am.
Do you understand everything, honey?
Yes.
Okay, all right. Okay, so the meeting is for questions, if you have any questions or not. Pilar, do you have another question?
No, thank you.
Okay, sweetheart. Okay, that's it. That's all we're going to do. You know what I'll do with you? I tell you what, Edito and Pilar, I'm going to read a story for you, okay? Is that okay with you if I read the story for you?
Yes.
I will read
Yes.
you a story, okay? Let me pull the story up on the screen. 1 second. I will read the story for the week to the two of you since you are here. Okay? This meeting is only supposed to be for asking questions, but since you're here, I will read it for you, okay? 1 second, I'll pull the story up. Give me 1 minute. Let's find our story. Our story is earthquakes, right? Just 1 second. Today was the 13th. Oh, folder's empty. Hang on. Let me check here. There it is. Earthquakes. This is our story, right? I will read this for you, okay? If you want to open your cameras, you can open your camera so I can see you. Okay? I don't have a camera on the computer because I'm at school. But if you want to open your cameras, I'd love to see your faces. All right. Earthquakes by Sneed B. Collard III. A shifting planet. We like to believe that the ground under our feet is solid and secure. People who have felt the ground shake know differently. They have lived through an earthquake. Earth's crust resembles a jigsaw puzzle more than a solid sphere. Like a puzzle, the crust is divided into different pieces that fit together. These pieces are called plates. Earth's plates float on top of a layer just below the crust called the upper mantle. The upper mantle is solid rock, but it behaves like a thick gel. Heat from deep inside the earth moves through the rock and causes it to slowly swirl and flow. Remember, what we are reading is expository text, okay? Expository text is text that gives you facts and information about a topic. Our topic in this case is earthquakes. All right, we just had Farida join us. Farida, we're reading the story because we finished the questions. After I read the story, I will ask you if you have any questions, okay? Because
Okay.
this meeting is about questions only. So I'm just reading for them because we finished the questions, all right? So you listen and then I'll ask if you have questions at the end, okay?
Okay.
Okay, honey. All right, so let's continue. Dr. Inez C. Fuentes is a seismologist, someone who studies earthquakes. She likes to compare the movement of Earth's plates to boiling milk. When you boil milk, she says, you get that little surface layer of cream on top that moves and dances around. That's what's going on in the earth, except the earth's crust is much harder than a layer of cream. So she's comparing here the earth's plates to boiling milk, okay? Remember we said this week one of our literary terms was compare and contrast. Compare to talk about what's alike, contrast to talk about what is different. As the mantle boils, it pushes and pulls the plates above it. It's at the edges of these plates, Dr. Cifuentes explains, where we have most earthquakes. All right, so she's explaining to us where earthquakes occur. Earth's largest quake, a first-hand account. This is a sidebar where they're giving us information about the earthquake, okay? And this is an earthquake that the doctor actually lived through. Earth's largest quake, a first-hand account. Dr. Inez C. Fuentes became a seismologist for a very good reason. A seismologist is someone who studies earthquakes. She and her family lived through the largest recorded earthquake in history. This was the 1960 earthquake that struck Chile. As Dr. C. Fuentes explains, in April 1960, my family moved to Santiago, Chile. Just a few weeks later, on May 21st, we were woken up by strong shaking. Then 33 hours later, a gigantic earthquake hit the southern part of Chile. and with it, an enormous tsunami. About a year later, we took a trip to the northern end of the earthquake zone, and that's where I saw that the land had actually been raised up a meter or so. I saw these huge changes, and that impressed me, that the earth could actually do that. Later, as a graduate student, I wanted to know how big that earthquake was, how long it lasted, and whether it was preceded by a slow earthquake. I worked on this problem for 4 years. I was able to calculate that Earth's largest recorded earthquake had a magnitude of 9.5. I also confirmed that a slow precursor, forerunner, had occurred 15 minutes before the main earthquake. I am very proud of this work. So she was able to go to the site and she did testing and she figured out that this was the biggest earthquake that the earth had ever had. And she measured it on the scale at 9.5. 9.5 is a very serious earthquake, and it caused much destruction. Okay? All right, and she also figured out that 15 minutes before the main earthquake hit, there was a smaller earthquake before it. Okay? Let's move on. Whose fault is it? Earth's plates crash together, spread apart, and slide against each other. Wherever they do this, they cause breaks in Earth's crust. Seismologists call these breaks faults. Remember the word fault? Fault, when we say it's your fault and we try to blame someone for something, the word fault has multiple meanings. The word fault also is a break in the Earth's crust. Okay, so this is a multiple meaning word, fault. Usually the blocks of rock on each side of a fault just sit there stuck together. But when enough pressure builds, the two sides of the fault can suddenly shift or slip. This sudden movement releases waves of energy. These waves travel through the earth. We feel them as earthquakes. Most faults do not slip and cause earthquakes. Around the globe, however, active faults cause hundreds of earthquakes every day. Most are too small for us to notice. Once in a while, Earth unleashes a whopper. Okay, a whopper means something really big, okay? Like the Whopper sandwich at Burger King, it's supposed to be a big burger. The whopper means something really big. I want you to notice at the bottom of the page here, there's a diagram with the arrows that shows us how a fault occurs, how the break in the Earth's crust happens. Okay, this is also one of our literary terms, diagrams. All right, measuring earthquakes. Seismologists record earthquakes using machines called seismographs. These measure shaking or ground movement. After an earthquake, scientists read their seismographs. They use their readings to calculate the earthquake's size or magnitude. Magnitude scales are set up so that each whole number is 10 times larger than the number before it. A magnitude 7.0 earthquake, for instance, is 10 times larger than a magnitude 6.0 quake. Truly giant earthquakes happen about once a year. These are quakes with a magnitude of 8.0 or greater. They occur only on very large faults and can cause severe destruction. Dr. C. Fuentes explains, the only way you can get an earthquake like the 2011 Japan earthquake is where one of Earth's plates is sliding under another one. This is the only kind of place where you have a fault long enough and wide enough to release that kind of energy. Okay, it says here that those very large faults can cause severe destruction. We know the word severe means serious, and we know the word destruction means damage or ruin. So we're talking about serious damage or serious ruin. Okay? Seismologists gave the 2011 Japan earthquake a 9.0 magnitude. It was the fourth largest earthquake ever recorded. They believe that the earthquake occurred on a fault more than 150 miles, 250 kilometers long. It shook Japan for 3 to 5 minutes. It was so powerful that it altered the geography of the country. Surprisingly, it wasn't the shaking of the ground that did the most damage. A massive wave proved much more destructive. Here it says that it altered the geography. That means it changed the geography of the land. Okay? Tsunami terror. When an earthquake occurs under the ocean, it often moves a substantial amount of water above it. Substantial means a large amount. This creates a fast-moving wave called a tsunami. Out at sea, the wave may be only a few feet high. As it reaches shore, however, the wave can tower into a monster. It can hurl water for miles inland. Tsunamis can travel thousands of miles. In 1960, Earth's largest recorded earthquake struck the country of Chile. It produced tsunami waves up to 82 feet, 25 meters high along the coast. The tsunami also raced across the Pacific Ocean at a speed of more than 150 miles per hour. It struck the shorelines of Hawaii, Japan, Alaska, and other places. Hundreds of people drowned. Okay, so this was a very bad tsunami and many people died. The 2011 Japan earthquake produced tsunami waves more than 30 feet, 10 meters high. The 2004 Indian Ocean earthquake in southern Asia produced 50-foot, 15-meter tsunamis. These tsunamis engulfed entire cities and shorelines. The waves swept away buildings, cars, and people. Japan, southern Asia, and Chile had experienced many powerful earthquakes and tsunamis before. Why were so many people unprepared? Predicting earthquakes. Seismologists are very good at measuring earthquakes. However, they still can't predict when earthquakes will happen. There was a time, Dr. Cifuentes explains, when I think scientists felt that predicting earthquakes was just around the corner. That means they were about to figure out how to do it, that they were going to be able to predict earthquakes very soon. But it's clear now that it's not around the corner. In fact, some have given up entirely on predicting earthquakes. One reason that earthquakes are unpredictable is that scientists cannot collect enough information to understand where and when an earthquake might happen next. Although scientists have placed special instruments in many earthquake zones, earthquakes still surprise us. Scientists, for example, have believed the next big earthquake in Japan would happen farther to the south, closer to Tokyo. Instead, it struck farther north. Unpredictable here means that we can't guess what is going to happen. Okay, we don't know how to predict what will happen. It's impossible for us to guess. All right. Planning for earthquakes. Even though we can't predict earthquakes, we can prepare for them. Many seismologists help make information available to people so they can plan and respond to earthquakes. This is especially important near coastal areas. Once the shaking goes on for more than 30 seconds, Dr. Cifuentes says, it's pretty simple. You have to run away from the ocean and run uphill. You have maybe 15 or 20 minutes to reach higher ground. Okay, you're running away from the water that's going to come in the waves. How cities are built also affect how many people survive an earthquake. Cities in many countries have special building laws. Buildings must be strong and flexible. That way they won't collapse during an earthquake. Remember, collapse means to fall down or to cave in. In some countries, however, buildings are often poorly built. The 2010 Haiti earthquake, for example, killed between 46,000 and 316,000 people. Unlike the earthquake in Japan, many of these people were killed by collapsing buildings and falling debris. So in Haiti, the buildings fell down on the people and caved in from the damage. However, earthquakes don't just destroy, they also create. They help make the mountains, coast, and other landscapes we see around us. Dr. Cifuentes explains, this is worth remembering as we learn how to predict and survive earthquakes in the future. Okay. When we have earthquakes, it can create mountains, the coastline, or other landscapes that we see. What do we do during an earthquake? If you're indoors and if you're outdoors. Indoors, drop to the ground and crawl under a sturdy piece of furniture until the shaking stops. See the kids under the table? Stay away from glass, windows, outside doors, and walls, and anything that could fall, such as a hanging light or fan. Stay in bed if you are there when the earthquake strikes. Protect your head with a pillow. Only move from the bed if there is a heavy light or fan above you. Put the pillow over your head to protect in case anything falls. Use a doorway for shelter only if you know it is strongly supported. Stay inside until the shaking stops and it is safe to go outside. Do not use elevators because the elevators can fall down. If you are outdoors, move away from buildings, street lights, and utility wires. Avoid any space where there is falling debris, such as glass. Once in the open, stay there until the shaking stops. Okay, so this is how to protect yourself from earthquakes, all right? I did a grammar lesson for you today. I made a separate video on nouns ending with Y. Make sure you take a look at that, okay? Are there questions from anybody? Does anybody want to raise their hand and ask any questions about anything for this week? No one has questions? I'll open your mics for you so that you can say something if you want. No questions from anyone? You all know everything? You're all so smart. I know you're smart.
Yes, I understand.
Anybody have a question?
I understand
you understand?
everything, but yeah,
I'm
but I
glad.
need to ask you a question.
Okay, go ahead.
Can you tell us what is going? What are you gonna like? What is going? Like what are we gonna do in the narrative?
In the narrative?
Yeah.
In the narrative project?
Yeah.
Yes, Pilar asked me that same question at the beginning of the meeting. I will tell you again. The personal narrative project, you have to write a story about yourself, something that happened to you, because that's what a personal narrative is a story that happened to you. You will make a sequence chart where you list the events in the order that they happened, okay, just like the sequence charts that I showed you in the videos. And you will then take that information and use it to write your paragraphs, okay? After you write your paragraphs describing your event that you are telling us about, you will draw an illustration about what your event is, okay? You'll put this all in your journal. Now, in your journal, I have your journals from last year for those of you who left them with me, but you can use any paper to put them in for now until we get back together again, hopefully to see you. You will take a video of yourself reading your journal and explaining to us what your picture is. Okay, so first thing you do is write the sequence chart that lists the events in order. The second thing you do is write the paragraphs. Third thing you do is draw the illustration. The fourth thing you do is take a video of you reading the narrative and telling us what your illustration is. Okay, and send me your videos. Okay? You understand?
Yeah. Thank you.
Yes?
Yes.
Okay, good. All right, and I'll be waiting for your videos. I'm going to show your videos to your classmates so they get to see you. Okay, I'm going to show them the videos that you send me. Adito, do you have a question?
Okay.
Then I give it to you.
I can't hear you.
When do we give you the?
The project is due on the 18th, so you have to send it to me by the 18th, okay? You can send it to me by the 18th so I can prepare it and get it ready because I want to show it to your classmates. Okay, so it's due next Sunday. Okay? Anybody else have questions? No more questions for today?
No.
Yes, Rita. No, no questions? Okay. Adito, any questions?
No.
No. Pilar, any more questions?
No.
All right, then I'll see you guys in the next video, okay? Make sure you watch the videos. All right? See you guys. Nice to talk to you.
Bye.
Can you open your camera so I
You
can see your
too.
face? I miss you guys.
Sure.
I wish you were here, but I understand that you need to stay home and be safe. So I want to see your face. Hi, Farida. Pilar, can you say hi? Adito, can you say hi? Can you open your camera so I can see you? Hi, Farida. I don't have a camera at school to open to
Bye.
say hi. Hi, Pilar. I see you guys. Adito, where are you? There you are. I'm so happy to see you all. And I will see you very soon, okay? Bye-bye.
Okay.
Bye.
Bye.
Bye.